Hello, class. We will continue the recorded lectures for section 6.1. This is the composition of functions. And we are going to now move into composition of functions and talk about how domains work with the composition of functions. And so the example we're going to do is what I have up here on the whiteboard. And this is the idea of two functions now where the domains of both functions aren't all real numbers. And so what's the domain of the f function? Well, I think we remember that all values of x such that x does not equal -2, right? And then for the g, the domain of g is all values of x such that x does not equal +1. And so when you plug these numbers into the appropriate equations there, you would get a denominator of 0. Can't divide by 0. So that's why it's not in the domain. But what if you have this idea, or if you do f of g of x? So when you do that calculation, and we also have to think about the domain. So the first thing you got to think about is if you're going to plug a number in, right? The number starts in g, right? The x value would be a number. And so you can't plug the number 1 in, right? So in this case, when we do this calculation, x cannot equal 1. Because if I plug 1 in, you don't have a real number, so that doesn't make any sense. So that's the first strategy. And then the next strategy is see what you end up with. And again, whatever you end up with, you can't plug those bad numbers in either. So it's the input and the final equation that you get. So how does that work with regards to this crazy fraction thing now, right? So now we have this crazy fraction thing. So we're going to plug 4 over x minus 1 n for f of x. So that would be 1 over 4 over x minus 1 plus 2. And now you're looking at that and saying, how do we deal with something that crazy, right? And so when we take a look at this, what you want to do is you don't want a fraction and another fraction idea with this, right? So the strategy would be is that if we take this and multiply both the top and the bottom by x minus 1, we'll be able to kind of smooth things out here with this 4 over x minus 1. So when you do that, you have 1 times this. What we have on the top is x minus 1. So what do we have on the bottom? Well, this times this will cancel, right? And so you'll have a 4. And then you get plus 2 times x minus 1. So you see how you kind of finagle that by multiplying the top and bottom by the same denominator we have down here to cancel it out. So just finish the algebra up here. And you would get 4 plus 2x minus 2. And so if you combine like terms, you get x minus 1. And this would be 2x plus 2. All right? So this is the f of g of x. So now what is the bad point here? Well, the bad point here would be 2x plus 2 equals 0. And so that would be 2x equals minus 2. And so x equals minus 1. So the domain or the bad point for this is minus 1. And the bad point for g of x was plus 1. So the domain of f of g of x are all values of x such that x does not equal 1 and minus 1. So that is kind of the strategy when you set these up with regards to the domains. It's the input, and then it's the final. And you combine all bad values. If they're both the same, you don't have to run them twice, of course. But here you could see that we had a bad value of 1 for g of x. And then the final equation had a bad value of -1. And we had to put both of those in the domain. Okay, let's do one more of these. So let's do this problem, f of x. So you're actually doing a composition of a function inside itself. And when you do that, you just treat it exactly the same way, 1 over x plus 2. And then when you plug that in, you get 1 over x plus 2 plus 2. And then what you do is you multiply the top and bottom by x plus 2 again. Just a good review here. And so 1 times x plus 2 is x plus 2. And then this will cancel out with that. And you get plus 1 and then 2 x plus 2. So a little bit more algebra, since we are in an algebra class, plus 2x plus 4. So this looks like it would be x plus 2 over 2x plus not 1. 4 plus 1 is 5. So what is the domain? Well, first of all, you go back to the original equation, and x cannot equal -2. So that's part of our exclusion of the domain. And the second one is 2x plus 5 cannot equal 0, right? So that would be 2x cannot equal -5. And so x cannot equal -5/2, which is -2.5. So the domain of f of x are all real numbers of x such that x cannot equal -2 or -5/2. So again, strategy, the input function, look at that domain, and then the final function, you look at that domain. So let's talk about decomposition of functions just briefly. And so we don't use it a lot here in algebra, but when you get to calculus, you'll be using it more. And you'll see that like the chain rule aspect of derivatives are very useful, understand a little bit of decomposition. And when you take a look at that, what you're trying to do is you're trying to make a complicated function into two simpler functions that you convolve together or compose together. Idea of composition. And here's a good example. So say like I have a function, so let's call it h of x is 3x minus 1 to the 4th power. And the idea is you want to find an f and a g that are simpler that you could do this with. And that's what we mean by two simpler functions. And you could see that the 4th here is going to be f to the 4th. So the way to think about this is that if you do f of x equals x to the 4th, then g of x is just what's going to go inside there, right? So that would be g of x equals 3x minus 1. And you see when we do this, it would be f of 3x minus 1. And when you plug that in, it would be 3x minus 1 to the 4th. So you're probably saying, why do we have to do this? You'll see. Just stay tuned for those of you heading off to calculus. Let's just do one more. So say like you had this, h of x equals the square root of 6x squared plus 5. And again, you wanted f of g of x. So what you would do is you would set g of x, what's inside there. And so that would be 6x squared plus 5. And f of x equals square root of x. So you'll see that there are other ways to come up with two functions that will compose and give you the same. My strategy always is try to find the simplest one. And you can see that the square root provide you with that option, and the x to the fourth provide you with that option as well. So that ends this section of the introduction of composition of functions, and we'll move on to section 6.2 next.